Welcome students for the chemistry lecture, physical chemistry, paper number 11. And now you are going to study the electromotive force chapter. And in that chapter you have studied what is cathode, what is anode, how the cell is constructed, then the IUPAC conventions regarding the representation of cell. Now we are going to study the Nernst equation. You know, the Nernst equation, it is derived from the Gibbs free energy change under standard conditions. And as per the IUPAC conventions, the E0, that means standard EMF of the cell, it is equal to standard reduction potential minus standard oxidation potential, or simply you can write E0, it is equal to ER minus EL, or oxidation at left hand electrode, reduction at right hand electrode. Then the free energy change in the electrochemistry, it is given by the equation delta G, it is equal to minus NFE, where delta G, it is the change in free energy, N, it is the number of electrons transferred in the reaction, that means from oxidation electrode to reduction electrode, that is the N, and F, it is the Faraday constant having value 96,500 coulomb per mole, and E, it is the potential difference. Remember well, this equation, it is the bridge between electrochemistry and thermodynamics, because this term delta G, it is from thermodynamics change in free energy, and this is from this term, it is from the electrochemistry, that means E, it is the EMF or potential of the cell, F, it is the Faraday constant, and N, it is the number of electrons involved in the cell reaction. Then this equation, it is also given as a maximum work done. So we equate W max, it is equal to delta G, and when the cell is spontaneous, remember delta G, it always decreases here. Then under the standard conditions, we can write this equation as delta G0, it is equal to minus N F into E0. Here E0 is positive, the reaction is spontaneous, and when E0 is negative, the reaction is non-spontaneous. That means EMF of the cell, when it is positive, the reaction is spontaneous, and when E0 cell EMF is a negative, then the cell reaction is non-spontaneous. From the thermodynamics, the Gibbs energy change under non-standard conditions can be related to the Gibbs free energy change under standard equation, and that equation is here delta G, it is equal to delta G0 plus RT ln Q, where this Q is a reaction quotient, and remember that this Q, it is just similar to the equilibrium constant, but the activities in the equilibrium constant, they are not reached at the equilibrium condition. That means certain arbitrary values. Here the ratio of concentrations of product divided by concentrations of reactant, or ratio of activities of product divided by activities of reactant, and all these activities, they are not at a equilibrium condition, and it is given by this reaction quotient Q, where this R, it is a general gas constant, T, it is a absolute temperature, this Ln, it is a natural log, and delta Z0, it is a free energy change in a standard state. So substituting delta G equal to minus NFE, and delta G0, it is equal to minus NFE0 into the above equation, this equation, we get this equation. Here NFE minus NFE0 plus RT ln Q, we get this equation, and dividing this equation by minus NF. Remember, dividing this equation by minus NF, we get here E, here E0, and here minus RT by NF into ln Q, where this ln, it is a natural log to the log E, and by changing this natural log to the log base 10, we can write E, it is equal to E0 minus 2.303 RT by NF into log to the base 10 Q. And this is the Nernst equation for cell EMF, or for any electrode we can calculate the electrode potential by this equation. Remember well, according to the Nernst, EMF of any cell or any electrode, it is given by E, it is equal to E0 minus 2.303 RT by NF into log to the base 10 Q, where Q, it is a reaction quotient. Then again, at a standard temperature, that means when temperature it is equal to 298 Kelvin, this ratio 2.303 RT by F, it becomes equal to 0.0592 volt, and by putting this value in the equation, we get E, it is equal to E0 minus 0.0592 volt upon N into log to the base 10 of Q. Again, where this Q, it is a reaction quotient. Here, the equation indicates that electrical potential of the cell depends upon the reaction quotient Q. As the redox reaction proceeds, reactants are consumed, and thus concentration of reactants decreases. Conversely, the product's concentration increases due to the increase in reaction quotient Q. As it happens, the cell potential gradually decreases until the reaction is at equilibrium condition. And remember well, at equilibrium condition, delta G, it is equal to 0 here, and when delta G, it is equal to 0, in this equation here we have reaction quotient, it is equal to equilibrium constant, and EMF of the cell, it is equal to 0. Therefore, the Nernst equation, it becomes as 0, it is equal to E0 minus RT upon NF into ln equilibrium constant. And at room temperature, here we can write this equation as 0, it is equal to E0 minus 0.0592 volt upon N into log to the base 10, here K equilibrium, that is equilibrium constant, and by using this equation we can calculate the equilibrium constant here as N into E0 upon 0.0592 hold. This above equation indicates that the equilibrium constant is proportional to the standard potential of the reaction. Remember, by using this equation, we can calculate the equilibrium constants of variety of reactions. Then we will see the single electrode potential here. Single electrode potential, that means the tendency of an electrode to lose or gain electrons it in contact with its own ions. And remember that there is no any instrument for measuring a single electrode potential up till now. So we have to combine our electrode with the another standard electrode, and that standard electrode, it is usually taken as hydrogen gas electrode. And here hydrogen gas electrode, it contains the platinum electrodes, and it is dipped in a solution containing H plus ions, and hydrogen gas at standard pressure or 1 atmospheric pressure, it is bombarded on the electrode, and it is coupled with the another electrode. And usually the EMF of the hydrogen electrode, it is given by this equation, and this equation shows that the EMF of the hydrogen electrode, it totally depends on activity of the H plus ions, and the concentration of H plus ions when it is equal to unit or 1, then at 298 Kelvin and 1 atmospheric pressure, that means at a standard condition, the EMF of hydrogen electrode, it is taken as 0 volt, because log of 1 upon activity of concentration of H plus ion, it is we have taken as 1, and it becomes equal to 0. Therefore, the standard reduction potential of hydrogen electrode, it is always 0 volt, and this electrode, it is coupled with any another electrode, and due to this, as the hydrogen electrode potential is 0, we can measure a single electrode potential here. So if you have any doubts, any queries, then you can contact me, and probably we will begin the lectures offline on Monday. So have contacts with your teachers so that you can understand well. Thank you for your listening properly. Okay.